On a quiet night in September 2025, a man in his backyard in Austria changed astronomy forever. He wasn't a NASA scientist. He didn't have a billion-dollar telescope. But what he saw through his $2,000 backyard scope shouldn't have been possible. An interstellar comet older than Earth, born around a star we'll never see, suddenly exploded in emerald light. Not over days. Not over hours. In under 15 minutes. And right now, we might be watching our sun strike an alien world for the very first time. Meet Comet Vesper. Officially. C/2025 S1. Only the third confirmed visitor from beyond our solar system. It's been drifting through interstellar space for over 1 billion years. Then, as it swung past Jupiter, something changed. Amateur astronomer Thomas Lehman had been tracking it for weeks. But on September 20th, his screen lit up like a Christmas tree. The comet's brightness spiked 300%, and its coma turned a vivid electric green. He checked his gear. No glitches. No lens flares. This was real. Within hours, 2 veteran comet imagers in Namibia, Michael Yeager and Gerald Raymond, pointed their scopes at the same spot. And what they saw stopped them cold. It wasn't just brighter. The tail rippled like a wave moving through water. A sharp kink traveled outward from the nucleus frame by frame. This isn't how comets behave. They're slow. Predictable. Icy snowballs. But Vesper? It looked like it switched modes. Like a cosmic light switch had been flipped. That eerie green glow? It's diatomic carbon. C2. When sunlight hits these molecules, they fluoresce green just like a neon sign. Every comet has some. But this much, this fast? Unheard of. It means massive amounts of ancient ice just vaporized, releasing gases sealed since before Earth existed. Now, here's where it gets wild. Just 5 days earlier, the sun fired off a monster coronal mass ejection, a billion-ton blast of magnetized plasma. And space weather models showed it was on a direct collision course with Vesper. Impact window? September 23rd to 24th. The flare? Peaked September 20th to 21st. Close enough to raise eyebrows. Too close to ignore. So what really happened? Scientists have 3 leading ideas. Theory 1. A crust cracked open. Comets are fractured, ancient, and layered. Heat from the sun could have shattered a decades-old crust, unleashing a buried reservoir of ice. That would cause a slow, sustained brightening. Theory 2. The solar storm hit it. A CME isn't just particles, it's a magnetic shockwave. When it slams into a comet's atmosphere, it compresses gas, heats it, and can twist the tail like a rope. This would cause a fast, sharp spike then fade. Theory 3. It's tumbling. If Vesper spins chaotically, a dark patch might rotate into sunlight, absorbing extra heat and triggering a short outburst. That would mean repeating flares on a regular cycle. Here's how we tell them apart. Watch the light curve. Amateur astronomers worldwide have been logging Vesper's brightness every 20 minutes. And the data? It spiked hard, then faded within 90 minutes. No repeat pulses. No slow rise. That pattern matches a solar impact, not internal cracking or rotation. But here's the real reason this matters. Vesper isn't from here. It formed around another star. Its ice, dust, and chemistry are alien. When it flared, it didn't just glow, it peeled back its skin. For the first time, we're seeing pristine material from another planetary system untouched by our sun. Unchanged for eons. New molecules appeared in its spectrum. Cyanogen. Formaldehyde. Weird carbon ratios. Clues to how planets form around distant stars. But Vesper is leaving. Right now, it's still bright enough for mid-sized telescopes. In 6 weeks, it'll be too faint to study. By next year, it vanishes into interstellar space forever. This is our only chance to analyze a piece of another star system. Delivered to our doorstep. And none of this would have been caught without amateurs like Thomas Lehman. Big telescopes like Hubble get a few hours on a target, then move on. But backyard astronomers? They watch every single night. They're the eyes on the sky when professionals aren't looking. And this time, they caught history. But there's one more twist, something that's got scientists whispering. Vesper shows almost no non-gravitational acceleration. What does that mean? Most comets drift off course because outgassing acts like tiny thrusters. But Vesper's path? Suspiciously clean. Is its ice different? Is its nucleus denser? Or do interstellar comets play by different rules? So what do you think caused the flare? Was it a solar storm slamming into an alien world? Or did ancient ice finally crack open? After a billion years in the dark? Drop your theory in the comments, I read every single one. And if you're fascinated by real-time cosmic discoveries, hit subscribe. Because the next interstellar visitor could show up any day now, and when it does, you'll want to be watching. We live in an incredible time. You don't need a PhD or a space agency to witness the universe's secrets. Sometimes, all you need is a telescope, a clear sky, and the courage to look up. Because out there right now the cosmos is writing its next chapter.